All right, Algebra 2 people, here is your solutions in case you had trouble with the 9.8 big ideas. So these first couple problems are where you're using your composite properties. So you're going to want to have those notes handy because you don't want to have to memorize those. So remember that tangent of, well, let's figure out which we're going to do, a plus b or a minus b, and that's the big thing. So notice here I have negative 15. The hardest part is what plus what, that is a special triangle, will give me a negative 15. Well, we've seen how to get a positive 15, so if we just rearrange this, 30 degrees minus 45 degrees, that would equal a negative 15. So we're using the tangent a minus b, which is tangent a minus tangent b over 1 plus tangent a tangent b. We're using that identity. All right, and you're probably going to want to have a little unit circle, which I know you have on some of your other handouts handy. So we're going to expand this. This becomes tangent of 30 minus tangent 45 all over 1 plus tangent 30 times tangent 45. And then what we do is look at your unit circle, and on your unit circle you should see that the tangent of 30 is going to be 1 over rad 3. Remember, it's the opposite over the adjacent, so the y value divided by the x value. Tangent of 45, since 45 your x and y are the same, will be minus 1, and then this becomes 1 plus 1 over rad 3 times 1. So we have a really ugly fraction over a fraction, but we did one of these in the notes. So what I'm going to do is multiply top and bottom. I want to get rid of that denominator, so I'm going to multiply top and bottom by rad 3. So notice I also didn't rationalize because it'll come out in the end. So my new equation so far, so when I distribute this to both, I'm going to get 1 minus rad 3 over 1 plus rad 3, which is not allowed because you have a radical in the denominator. So we're going to multiply top and bottom by the conjugate of what's in the denominator. So 1 minus rad 3 times 1 minus rad 3. Now, continue that over here. So on top, we're going to have to distribute. That's going to result in the first terms, 1 times 1. The outer terms is just going to be minus rad 3. Then we have the inner terms will be another minus rad 3. And then a negative rad 3 times a negative rad 3 is going to be a positive 3. On the bottom, this is your a squared minus b squared factored, difference of squares factored. So the first term squared is 1 minus rad 3 times rad 3 is 3. So now we can start to simplify this. So 3 plus 1 is 4 minus 2 rad 3 over a negative 2. And so I can simplify this because there's a common factor of 2 everywhere. So on top, I'm going to factor out 2, which gives me 2 minus rad 3. And on the bottom, we had a negative 2. So that goes to 1, and I end up with, when you distribute that negative, positive rad 3 minus 2. I always like to write my positive numbers first. So we had to distribute this negative to both of those terms, and that would be your final answer. Whew, that took up all my space. Okay, so then we have sine negative 165. So I'm going to deal with this one as, we're going to do a couple identities here. I can rewrite this as sine negative 45 minus 120, which you have on your unit circle. That would equal a negative 165. And so I will use the sine a minus b identity. So that expands as sine a, which is negative 45, cosine 120, minus, because we're doing the minus 1, now it's going to be cosine negative 45 times sine 120. And when you go to your unit circle, you will see that the sine of negative 45, so that's the same thing as 315, is going to be a negative rad 2 over 2. I'm just getting these items from these values from your unit circle. At 120 degrees, remember cosine is the x value, that is going to be a negative 1/2. Minus cosine of negative 45 is actually a positive rad 2 over 2. And sine of 120 is rad 3 over 2, positive. So we have a common denominator of 4, and on top I've got positive rad 2 minus rad 6. And that, your answers always look like that. So if you did the notes, you notice we had an answer like that for the other sign problem. All right, now we have down here 11 and 13, where we have this initial information to help us set up our triangle. So I'm going to kind of do the triangle over here. Since they're in different quadrants, I can put them on the same grid. So I'll do this one is the first quadrant, because this is 0, pi over 2. So I'm going to be drawing a triangle, and that's going to be A. So how do I label the sides? Well, they're telling me the cosine of A is adjacent is 4, hypotenuse is 5. That means my opposite is going to be 3. Now I'm going to do the other triangle in a different color. So this other triangle, triangle B, is between 3 pi over 2 and 2 pi. So that's going to actually be here. This is going to be awkward since I'm doing it on the same. You know what, let me move this 4 inside. I'm going to put my 4 here. Okay, that was the adjacent for that one. So for sine of B, so this is now your triangle B, the opposite is negative 15, and the hypotenuse is 17. Hypotenuse is always positive. And this is one of your Pythagorean triples, or you could do Pythagorean theorem, but this will turn out to be A, the adjacent for that one. All right, obviously these are not drawn to scale. I'm just labeling the triangles so we have what we need there. So on 11, what I'm going to do is I'm going to expand sine A plus B. So that's sine A times cosine B plus cosine A times sine B. And then we just substitute from each of the corresponding triangles. So sine of A, opposite over hypotenuse. Cosine of B is the adjacent over the hypotenuse. Cosine of A is the adjacent over the hypotenuse. And the sine of B is the opposite over the hypotenuse. So we have a common denominator, 5 times 17 of 85. And on top I've got 24 minus 60. So this will simplify out to negative 36 over 85. That would be the answer for number 11. If I do number 13, now that one's a cosine, so it'll be expanding cosine A, cosine B. So the cosine identity, again, go back to your notes. You don't have to memorize these. Then there's a plus. This will be sine A, sine B. And we go through the same process. We substitute from the triangles. So A triangle, the blue one, cosine is adjacent over hypotenuse. Cosine down below from the green triangle, adjacent over hypotenuse. Sine of A is 3/5, and sine of B, negative 15 17ths. So same denominator, 85, the 5 times 17. On top, this time I have 32 minus 45, and that is going to simplify out to a negative 13 over 85. And that would be that answer. Okay, down here, what are the solutions? So, multiple choice. So remember, to solve this problem, I'm going to isolate sine. So sine x equals, I'm going to add 1 to both sides, and then divide by this 2. So sine x equals a positive 1/2. So what you need to do is you need to look through your unit circle, and you're going to find wherever the y value is a positive 1/2. So remember, sine goes with your y values, and y values are positive here and here. So you will find that they will have the same reference angle, and it should be at pi over 6 and 5 pi over 6. So this would work, and that one would work. Those would be your two answers for that. On this next one, where is tangent x plus 1 equals 0? So let's isolate our tangent. Where does tangent equal a negative 1? Well, tangent, remember, is sine over cosine. So wherever those two have the same coordinate, which is all your 45-degree angles, but we want it to be negative, tangent is negative here and here. So this is going to be 3 pi over 4, and down here is 7 pi over 4. That's where the tangent is going to be a negative 1, where the ratio of the y over the x. So we have this answer, and we have this answer. Okay, so now we're going to do some solving using those composite sum and difference properties. So for 27, first thing I want to do is expand this. So this is your sine a plus b, which is sine, so there's x, and then cosine pi over 2 plus cosine x times sine pi over 2, and that supposedly equals 1/2. So now you look at your unit circle. What is the cosine of pi over 2? What you're going to find is it's 0, so that whole term goes away. Sine of pi over 2, the y value is 1. So what we're really solving is just cosine x equals 1/2. Remember, cosine goes with the x values, and your x values are positive here and here. So you will see we have to do it in radians, because that's what they give us here, 0 to 2 pi once around the circle. If you notice, at pi over 3, the x value will be 1/2, and down here at 5 pi over 3. So our answer is going to be both of those, pi over 3 and 5 pi over 3. Okay, so now we go on to number 28, and we're going to expand. So this is tangent a minus b, so that'll be tangent x minus tangent pi over 4 divided by 1 plus tangent x. Sorry, I should have turned off my notifications. Pi over 4, and all that has to equal 0. All right, so tangent of pi over 4, if you look on your unit circle, is always going to be 1. So I can replace those with a 1. So what I have here is tangent x minus 1 over 1 plus tangent x equals 0. Well, if I cross multiply this over to this side, this all simplifies to tangent x minus 1 equals 0, because 0 times anything is going to be 0. So those just kind of go away. I can now just set tangent x equal to 1. Remember, tangent is sine over cosine, or y over x when you're looking at your unit circle, ratio of the y value over the x value. That's going to happen when tangent is positive, which is here and here at the 45-degree reference angles. So at pi over 4 and at 5 pi over 4. So your answers here will be x equals pi over 4, 5 pi over 4. And now we have number 29. So cosine, ooh, this is going to be a long one. All right. Maybe I should do it. No, it's fine. I'll squeeze it in here. So this first one, this is going to be your A and your B. So this will be cosine x cosine pi over 6 minus sine x sine pi over 6. Then we are going to subtract and expand this. So here's my A, here's my B. So minus, and I'm going to put all of this in a parenthesis here. And you know what? This is going to be in my way. So we have, lost my place, cosine x cosine pi over 6 plus sine x sine pi over 6, and all of that equals 1. All right, well, this negative is going to get distributed. So notice that I have this first term minus this term. Those are just going to cancel each other out. So they're gone. And, oh, this negative distributes for a minute there. I was like, whoa, everything disappeared. So that became a negative. So I really have minus 2 sine x sine pi over 6 equals 1. So let's start to simplify. Sine pi over 6, we go to our unit circle, is equivalent to 1/2. So what I have here is negative sine x equals 1, which is like asking sine x equals negative 1. So you're looking on your unit circle, where does the y value equal a negative 1? And that's only going to happen at one place. That happens at 3 pi over 2. And that would be your answer. All right, now we are just simplifying. So what that means is you're just going to expand and evaluate. So tangent, again, here's a plus b, so that's tangent a plus tangent, sorry, not a, x, plus tangent pi over 1 minus tangent x times tangent pi. And if you look at your unit circle, the ratio at pi, this is the coordinate -1, 0 there. That ratio is going to be 0 because it's y over x, so that goes to 0. That means that whole term goes to 0, and this whole thing just simplifies to tan x. All right, last problem. So expanding, this will be a minus b. So cosine x cosine pi over 2 plus sine x sine pi over 2. So you look at your unit circle and you see that the cosine of pi over 2 is 0, so that whole term will go away. Sine of pi over 2 is 1, so this simplifies down to just sine x, which actually is a justification of your cofunction property. All right, so I hope that was helpful, and I don't think I'm done.